All right, this question looks scary. We've got a story on top of a quadratic equation. We don't get that a lot on the SAT. We usually have stories on top of lines. But nothing's really changed. We still want to just think about it as a quadratic equation, and especially because they use some kind of quadratic-y language in the question, we want to fixate on that. So this is our get back to basics strategy. This is not really about heights or projectiles. This is about quadratics. What do we say? Here we go. If y equals h of x is graphing the xy plane, which of the following represents the real-life meaning of the positive x-intercept of the graph? That word x-intercept has got to stick out in your mind and become the driving force of the question. We saw this on something else earlier. I forget the question number, but in that case, they cared about the y-intercept, and we had to think about what we knew about that. It was question 21. 21, the exponential model. That's what it was. Here, though, it's an x-intercept. What do we always know is true about x-intercepts? We know that the y-coordinate is 0, right? Because it's hitting a spot on the x-axis, so y is 0. So what is y again? Well, y is h of x. And what is h of x again? H is the height. So this is all a fancy way of saying that the height is 0. Now look at the choices. Go into them and ask, where is the height 0? Well, maybe it's the initial height. We'll get back to that. The maximum height is certainly not going to be 0 because that's not any height if it's 0. C, the time, well, that's wrong, at which the projectile reaches its maximum height. No. Again, we're looking for something that says the height is 0. And D kind of says that, the time at which the projectile hits the ground. When it hits the ground, it has no height because it's on the ground, which is 0. So there you go. That literally is just the story version of exactly what we wrote. That's why Get Back to Basics works. If we can think about it in simple algebra terms, then we're just really looking for a story that matches our algebra, right? So it makes it so much easier to understand what's going on. Now, why isn't A correct? The initial height. Well, that reminds me of another word that we do use for lines a lot. The initial value, in most cases, is going to be the y-intercept, right? Because if we think about it, that's where the time or the x is equal to 0. So most story questions that we get on the SAT are only going to be in the first quadrant, right here. We ignore the other quadrants, mostly because there's just not a lot of negatives in real life. So we tend to ignore them. And that's why the initial height, the y-intercept, is so important, is it's what happens at 0. We don't have negative time, so 0 is our starting point, and that helps us a lot for lines. But it also helps us here. The initial value, the y-intercept, is given by the c term in a quadratic that looks like this, a standard form quadratic. So the c term is the term with no x attached. In this case, it's 10, so the initial height of the projectile is actually 10 feet in this case. I don't care about the unit, but 10 feet. So look, we've seen this before with lines, but any story, if you can get it back to some simple thing, that's much better. And if it looks like y equals mx plus b, think in terms of y equals mx plus b. If it looks like a quadratic, think in terms of quadratics. Sometimes we'll have stories with wacky equations that don't fit our normal kind of view of things. But getting back to basics is about recognizing when the basic equations that we do know pop up in weird places. Get back to that basic equation, devoid of all stories, and you'll probably understand what's going on, and then you can reapply the story once you do. That's what makes this question so easy.